Alright students, here's a sleepy golden doodle, but he's participating in the classifications of triangles. He too agrees with me that the right isosceles is the best triangle out of all the triangles. Alright, nonetheless, let's get back to the math. Alright, so draw a sketch of each of the following triangles. If impossible, explain why. Alright, so obtuse isosceles triangle. Is this possible? Is it possible to draw an triangle with one angle greater than 90 degrees and two congruent sides? Well, the answer is yes. Alright, I'm going to say this is 110 degrees. Alright, then that's 35 degrees. That's 35 degrees. Alright, and then I'm going to just make up some numbers. This isn't necessarily correct, but then that'd be 5. That would be 5. And let's say this is 7. Alright, obtuse isosceles triangle. Cool. Alright, let's go down. Acute scalene triangle. Acute scalene. So that means all the angles are less than 90 degrees. And all the sides are different. Now watch this. You can kind of be a little bit clever. I'm going to say, well, this is 60 degrees. I'm going to say this is 59 degrees and 61 degrees. All super close to being the same. Furthermore, again, a little foreshadowing. Across the biggest angle, let's put the biggest side. I'm going to just make up some numbers. 8. And then across the second biggest angle, let's put the second biggest side. Again, a little foreshadowing. What does this mean? And then last, across the smallest angle, we'll put the smallest side. What does that mean? Stay tuned and find out. Cruising right along. Right equilateral triangle, all right? So remember, equilateral implies equilateral implies equiangular. So that means all angles 60 degrees. Well, right means one angle 90 degrees. All right, so right triangle means one angle is 90 degrees. Equilateral means equiangular, means all angles are 60 degrees. So I'm confused. In confusion, this one's impossible. If someone can draw a right triangle that's equilateral, that lies flat on a piece of paper, you get an A for the year. Then right isosceles, my favorite triangle out of all the triangles. Again, just a good looking triangle. Something like that. And again, this is a little foreshadowing. That's going to be both these angles will be 45 degrees, 45 degrees, 5, 5, and watch this. This is going to blow your mind. This last side, the hypotenuse will be 5 radical 2. All right, that's math we're going to learn later. But that is an accurate right isosceles triangle. Pretty cool stuff right there. Alright, so that's just some sketching. Again, I'm a really good drawer. You guys are probably impressed right now. But now we are going to do some graphing. Alright, this is going to be intense stuff right here. Alright, draw triangles whose vertices are 6, -1, 5, 2, and -2, 2. So let's go ahead and just plot these points. 6, so 1, 2, 3, 4, 5, 6. 6 to the right, 1 down. That was P. R is 5, 2. 1, 2, 3, 4, 5. R is up there. And then S is -2, -2. All right. So we got to classify this triangle, or we're going to show that this triangle is isosceles. So how do we do that? Well, That's side. How do we know the lengths of the side? Well, we got to use the good old distance formula. So we're going to use two techniques right here. Actually, we're just going to use one technique. We're just going to get really good at the distance formula. Now, I'm going to cheat a little bit. I'm going to be suspicious. If it is an isosceles triangle, I'm under suspicion that SR and SP will be the congruent sides. So let's only look at those two sides. So remember the distance formula. So to find the length of SR, it's the giant square root x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Alright, that's it. That's the distance formula. And then let's look at S and R. Again, order doesn't matter. I'm going to call R x1, y1, and S x2, y2. So remembering the distance formula is the first punchline. The next punchline is plugging in the numbers. And we got to be very careful. Alright, so I'm going to have 5 minus negative 2 squared plus 2 minus negative 2 squared. Alright, all I did was plug in the numbers. Now let me clean this up a little bit. 5 minus negative 2, 5 plus 2 squared. Excuse me. Hopefully that didn't scare you. Similarly, 2 minus negative 2 gives me 2 plus 2 squared. Alright, now we remembered the distance formula. We very carefully plugged things in and cleaned it up a little bit. Now it's just a series of easy computations. What do I mean by that? Well, what's 5 plus 2? 7. What's 2 plus 2? 4. Alright, so we got 7 squared now, 49. 4 squared, 16. Alright, so this is going to be the square root of 65. Neat. Alright, so we used the distance formula to find the length of SR, and we could plug that in the calculator. We get some decimal number slightly bigger than 8, because square root of 64 equals 8. Square root of 65 is bigger than the square root of 64, so it's a number bigger than 8. Anywho, now let's do the same exact thing, but we're going to do it for SP. So I'll keep S, x sub 2, y sub 2. That was kind of nice how everything kind of cleaned up nice. I'm going to call P x1, y1. So when I find the length of SP, again, I'm going to write the distance formula again too. I recommend you do it. Why? The more you write it, the better it's going to be stored into your long-term memory. Alright, now I'm going to plug everything in very carefully. And notice how I draw the giant square root each and every time. Alright, again, what I do is stuff you should do as well. I don't do it for fun. I do it to try to model what you guys should do. And then when I clean up everything, I get 6 minus negative 2, so 6 plus 2 squared plus negative 1 plus 2 squared. Alright, now we remember the distance formula. We carefully plugged everything in. We cleaned it up. Now it's just a series of easy computations. 6 plus 2 is 8. Negative 1 plus 2 is 1. So I get 8 squared plus 1 squared. And this is going to become square root of 64 plus 1, or the square root of 65. OMG. They are both the square root of 65. They both have the same side lengths, therefore it is isosceles. Alright, 2 equal side lengths, thus isosceles. Alright, we're going to save these next two for the last video.